All right, in this lesson, we're going to be talking about the primary trigonometric ratios, which we've already introduced. But by the end of today's lesson, specifically, we want to be able to use the sine, the cosine, and the tangent ratios to solve for the unknown sides or unknown angles in a right-angled triangle. So we'll start just with a bit of a recap here of stuff that we talked about in the last lesson here. We know that the trigonometric ratios, sine, cos, and tan, are the ratios of the lengths of specific sides in a right triangle. And we know that these ratios have the same values if the angles of the triangle are the same size. We spent some time figuring out, if we're given a right angle triangle, which sides are which in terms of our hypotenuse, our opposite, and our adjacent. So we know that our hypotenuse is always across from the right angle in the triangle. And if we have another angle in our triangle that we're given or that we're interested in, that we usually refer to as the angle theta, T-H-E-T-A, then the side in the triangle that is across the triangle from that angle is the opposite side. I'll just write OPP for opposite. And the side that is next to it in the triangle and is not the hypotenuse is our adjacent side. And the three primary trig ratios that we're using here are that sine of that angle theta is equal to the length of the opposite side divided by the length of the hypotenuse. That the cos of that angle is equal to the length of the adjacent side divided by the length of the hypotenuse. And finally, tan of that angle is equal to the length of the opposite side divided by the adjacent side. And these are all on the formula sheet that you have. So you're going to want to have that formula sheet in front of you as we're working our way through these questions here. So we can use these trigonometric ratios to find the lengths of unknown sides or the size of unknown angles in our triangle. Here are our three ratios here. So for solving these problems, we can kind of break this up into steps. We want to first, if we're given a triangle, we want to be able to label the sides. And this is going to be the same for any question that we do here. What we're doing in this question here is we're finding the length of an unknown side. They say find the length of side C in the triangle. Side C is this side up here across from angle C. But we want to label the sides in terms of our hypotenuse, our opposite, and our adjacent. So our hypotenuse is across from the right angle. They give us this angle 30 degrees here, so we want to use that angle to label our opposite side. Our opposite side is across the triangle from it, and our adjacent side is right next to it. Once we've got our sides labeled, we need to figure out which of these three ratios we're going to use to solve the problem. And a way of doing that is to list what we are given and what we're trying to find in this triangle. So we are given the angle. Okay, so our angle, let's say theta is 30 degrees. We are also given the length of the opposite side. Our opposite side is 10 centimeters. What are we trying to find? Well, we want to find the length of side C. Side C is our hypotenuse. So when we're trying to solve this question, we want to use the ratio that involves theta, the opposite side, and the hypotenuse. So when we look at our three ratios, we're going to use sine here, because sine has the angle, the opposite, and the hypotenuse in it. So our next step in solving this is to say, okay, we know that sine theta is going to be opposite over hypotenuse. So what we've done here is we have chosen our trig ratio. Choose sine, cos, or tan based on this given information. Once we've got this set up, we just have to fill in the information and then solve. So let's do that. Theta is 30 degrees, so we're doing sine 30 degrees. Our opposite is 10. Our hypotenuse is the thing that we're trying to find. That's side C. We just have to solve this for C. And to solve this, we can think of this as a proportion, just like we had back when we were working with similar triangles. We can cross multiply. So on the left-hand side, C times sine theta is going to give us C times sine 30 degrees. On the right-hand side, 1 times 10 is just going to be 10. And to get C all by itself, we can divide both sides by sine 30 degrees. So C is going to be equal to 10 divided by sine 30 degrees. And we can just punch this into our calculator. 10 divided by sine 30 gets us 20 centimeters. Okay. So let's do a second question where we're finding the length of the side, and we're going to follow the exact same steps. We want to find the length of side x in this triangle. So we're going to start. All right, this is our hypotenuse. It's across from the right angle. They give us this angle down here, 38 degrees. Across from that is going to be the opposite side. And next to it is going to be the adjacent side. What are we given and what are we trying to find? Well, we are trying to find side x. X is our opposite side. We are given that that angle is 38 degrees. And we are given the length of the adjacent side. Adjacent is equal to 3.7. So we want to choose the trig ratio that involves an angle, the opposite side, and the adjacent side. Tan theta is opposite over adjacent, so that's the one that we want to use. Let's fill in our information here. Tan of 38 degrees is going to equal, our opposite is x, our adjacent is 3.7. And then let's solve. Okay, we can cross multiply to get 1 times x is x, 3.7 times tan 38 degrees. So evaluating this, 3.7 times tan 38 degrees, punching this into our calculator, 2.89. And this is going to be in centimeters. So we're going to use this cross multiply every time we are trying to solve for the side. Multiply to solve for a side. The other thing they could ask us to do is to solve for an unknown angle. Most of this stuff is going to be exactly the same if we're solving for an angle, except for this method that we use at the end for the solving. So let's take a look at one of these. We want to find the sides of an unknown angle here. We're finding the measure of angle P in our triangle. Let's start by labeling our sides. This is our hypotenuse. The angle that we're trying to find is angle P, right? This is the angle that we're interested in. So we're going to use this angle to label our opposite and our adjacent. Let's list what we are given and what we are trying to find. We are given, well, we're trying to find angle P. That's our theta, okay? We are given the length of the adjacent side, which is 8, and we are given the length of the opposite side. Opposite is 5. So we want to pick the trig ratio that involves adjacent, opposite, and theta. Adjacent and opposite, we're going to be using tan, because tan theta is opposite over adjacent. So instead of theta, we want to figure out p. Our opposite is 5. Our adjacent is 8. Okay. Now this is where it gets different from the previous questions. We don't want to solve for the length of the side, so we're not going to cross multiply here. What we're trying to solve for is t inside. So what we're going to do is we're going to evaluate what's going on the left-hand side. We're going to keep tan p exactly the same, and then we're going to do 5 divided by 8 is 0.625. To get p itself, we have to do like the opposite operation to both sides. We have to do the opposite of tan. The opposite of tan is going to be inverse tan. Okay, tan to the minus 1, 625. Okay, so when we're punching this into our calculator, we're going to have to do like second or shift tan and then put in the 0.625. And that should give us that P is 32 degrees. Okay, so anytime we are solving for an angle, okay, we are going to be using an inverse trig, or trig to the I'll say the inverse, or the sort of the -1 thing, anytime we are solving for an angle. Okay, so we'll do one last question here where we're solving for an angle again, and we'll see at the end that we're going to have to use the inverse of whatever trig ratio we have to use. So find the measure of angle B in the triangle. So we know right away that this is going to be our hypotenuse. If we're interested in finding angle B, it's angle B that we're going to use to figure out which side is our opposite and our adjacent. So what are we given? What are we trying to find? We are trying to find, obviously, angle B is what we're trying to find. In terms of the sides, we are given that our hypotenuse is equal to 225, and our adjacent is 200. So we want to choose the trig ratio that involves the hypotenuse, the adjacent, and an angle. We want to use cosine, because cosine theta is adjacent over hypotenuse. All right, let's sub in what we know here. The angle we're trying to find is B. The adjacent side is 200. The hypotenuse is 225. Just like in the last one, the first step is going to be to divide what is on the right-hand side. So 200 divided by 225, and I get 0.8888, and so on and so on. So we want to use 4 decimal places here. Okay. 4 decimal places will give us enough accuracy that our angle is going to be correct. So if we're doing cosine of B is 0.8888, then B, we're going to have to do the inverse cosine of 0.8888, so on and so on. So subbing this into our calculator, we're going to do shift or second function cos, then 0.8888, hit the equal sign. Angle B should be 27 degrees.